Alright, welcome back. This is Michael. Right now, we're going to proceed to our third project. Of course, this is our topic for Arduino Basics for Absolute Beginners course. Okay, so let's go and build our Arduino project number 3. So this is the schematic diagram for our project. So right here, we have 3 components or 4. The Arduino Uno, R3, the resistor, and then the LED, and of course our new potentiometer. So right here in this diagram, we're gonna do a simple circuit that will adjust the light or brightness of the LED. And we are able to achieve that by using a potentiometer. The potentiometer is also called the variable resistor. Okay, so variable resistor, VAR, variable resistor. So what does this do is we will be able to adjust the resistance of the resistor. So it is also a resistor just like this one. As you will notice, there is similarities, okay, between the two because they have this symbol, the zigzag, and you will notice that this one has the arrow. This symbol shows that the resistance can be adjusted. So this is a potentiometer, and I will show you later how this works. All right, so our variable resistor or potentiometer is connected to the 5 volts, and the other terminal goes to our ground, as you can see. And in the middle, as you can see, there are 3 terminals, 1, 2, 3, and the third one is connected to our A0 in the Arduino board. Okay, while our resistor is connected now on the 9. As you can see, we have here the PWM. What is a PWM? Let's see accordingly to our Google. PWM in Arduino, to be specific. So Google says pulse width modulation or PWM is a technique for getting analog results with digital means. Okay, so digital control is used to create square wave, a signal switch between on and off. Okay, so I just want you to remember the word analog. Okay, so the analog means, if we will type, and of course remember this word, pulse width modulation. The keyword here will be the pulse. Okay, the pulse. It means it generates pulse. It generates or it emits pulse, or let's say it accepts pulse. Okay, so I will just try and click the images, okay, so that we can see the signal of a PWM. So as you can see, we have now the signals here, like this one. I'm gonna open it in a new tab for you to see. So this is an example of a signal of a PWM. Okay, what does this do? We can control the behavior of the electrons by using pulse width modulation and electronic components so that we can make some more using these electronic components by changing the intervals. As you can see, the duty cycle, analog write, 50 duty cycle. So we can transfer that to audio signal, etc. We can do a lot of things with the analog signal. Unlike with the digital signal, which gives us only high and low. Do you remember these two? Of course. They say they are the on and off. This is the on and then the off. While the PWM, this means a different thing. Okay, so it emits signals, or it produces signals which can be varied. All right, so that's why in this circuit, in our circuit, we will control the signal that is going to the LED by the use of our potentiometer. So by adjusting this, we will see the effect on the LED. And to achieve that, to do that, we need to open our IDE for the program of our circuit. So right now, as you can see on my right, I have connected already the wirings for the potentiometer and the LED circuit. Okay, so you will see that my VCC, or this is the potentiometer that I'm talking about. So this is the digital appearance. While if you will, if we will look closer, so there are three terminals. Okay, the ground, the signal, and then the VCC. If you remember VCC, as I've told you, VCC also means power. Okay, so this goes to our power source, 5 volts. And this one is the signal, and this one is our ground. So accordingly to our diagram, this should go to the pin to analog 0 or A0, and then the other terminal will be on the ground, and the other terminal to the 5 volts. Okay, where is it? Here. So as you can see, the terminal 2 goes to the 5 volts, and the other terminal is to our ground, and the third one is to our analog 0. And of course, we have some changes with our LED. Instead of putting it here in D13 or digital pin 13, we put it here in D9 because of the PWM output. Okay, because D9 and other pins, they can produce PWM signals. Unlike the D13 doesn't have the label of PWM, meaning to say that this can only provide high and low outputs, which is the on and off, while the D9 has the capability of producing pulse with modulation signals. So with a signal of the square wave, we can make this LED to have variation of light, or I mean to say the intensity of the light. We can adjust the brightness. Okay, so let's go back to our walkway. So I'm gonna share with you the link so you can see the actual wiring that I did. So there, as you can see, we followed the same procedure, the same connection, and of course the digital 9 pin is connected to our LED instead of the digital pin 13. Of course, the ground can be connected here or here. Okay, anywhere, but if there is a label for the ground, so you can use that. Okay, so let's go to our code. So this is our code. We declared the variables in the first 4 lines, and we put it here, the integer, that the variable pot pin, meaning to say the potentiometer pin, that is the short meaning for the pot or potentiometer. I've shortened the name pot pin, but of course you can always use any name which will describe the function or the reason why you put the variable name. So right now I use the pot pin and assigned it with the value of A0. This is the A0, as I've mentioned before, and int lead pin to 9, which we have done already, and int pot value 0. Here, I put the name or the word value. So we will understand that the value should be 0, meaning to say there is no value yet. When the Arduino would initialize, if the Arduino will receive the program and have power, it will start with a value of 0. Okay, so for once, the Arduino will run this instruction, void setup. Please set up the pin mode lead pin, which is assigned to the digital pin 9 as output. Okay, so the work of the pin 9 will be output. Alright, so here there is a bit difference with other programs that we have done so far. The void loop includes the pot value. This is also a variable name which I have set to 0. Instead of digital write or digital read, it has this function of analog read, meaning to say that it will read the analog input for pot pin. Okay, so pot pin is assigned to A0, so it will wait for a signal that would come in the AO pin. Okay, all right, so analog write, when there is signal coming from the pot pin, which is AO, it will write analog signal to lead pin with the pot value of divided by 4. As you can see, the analog write lead pin pot value divided by 4 right here. This means that whatever the pot value, this one, whatever value is detected, it will respond to the same with the analog write. So whatever is done to the analog read divided by 4, so the analog write will respond the same. Okay? Alright, so to see that in action, to better understand it, we will start the simulation right now. So I'm gonna show you the simulation. Of course, you can copy the code and the entire wiring diagram and show our schematic diagram. So right here, as you can see, there's no light with our LED, and I'm gonna turn the potentiometer on. As you can see, so it minimizes the brightness and maximize the brightness of the LED. Okay, this technique or this circuit we can use later to adjust volumes, to adjust certain lights, and control other devices using this potentiometer. So the value of the potentiometer is 10 kilo ohms. Okay, we have the value of 10 kilo ohms. So I'm gonna show you the actual on the next topic. Okay, maybe right now I'm gonna show you the actual right now for the our project. Okay, so let's remember this code, and I'm going to copy this. Okay, and open our Arduino IDE. Arduino, I'm gonna type the Arduino and look for the latest app. Okay, so I'm gonna open my Arduino IDE. I've already copied the code, so I'm gonna open a new sketch. Alright, so to see if the code is working. Alright, so this is the default code. I'm gonna erase this and insert the new code and start verifying. Okay, so as you can see, there are some errors, but it is not um, with the code. It has errors with other installation, so I'm gonna verify again to make sure. Okay, done compiling, meaning to say there is no error with the compilation. So I'm gonna connect my Arduino to my computer. So as yours, if you are following this, so let's open our Arduino IDE and follow me. So before I connect the Arduino, I'm gonna show you my wiring. Okay, so as you can see, I followed the same wiring. Okay, so there are different types of potentiometer. This one is the most common. Let me adjust my mic first, and I'm gonna show you the potentiometer. So it has the value of 10K, meaning to say 10,000 ohms. Okay, so that's one kind or type of potentiometer. Another one is something like this. Maybe you have bought a different potentiometer. It doesn't matter. What matters is the value of the potentiometer, which is the 10K. But you can use, if you don't have this kind of value, the exact value, you can use 1K, 100K. It depends on the situation, because the value that we have put in the code is the pot value divided by 4. Okay, if you remember the code. So it means to say whatever we do with the potentiometer, whatever value it generates or it produces for the resistance, it will be just equaled. The equal amount will be given to the LED. Okay? All right. So as you can see in our Arduino wiring, the ground and the 9 is already inserted, and then on the other end, the AO or the A0, the 5 volts and the ground. Okay, so this is the LED connection, and then this is the potentiometer connection. Okay, I hope you follow me. All right, so I'm gonna turn this to the minimum, to the left. Okay, that is the minimum. Well, it depends on the situation with my wiring. We will know which is the minimum and which is the maximum. Okay, so I'm gonna put this to my computer. Okay, so let's see what will happen. So as you can see, the code is not yet working, right? Because I have a different code from our last project. So what I'm going to do now is go ahead to our Arduino IDE and again verify the code to make sure, and then select the Arduino connection and upload the command or our program. Now as you can see with our Arduino, so as you can see now it's working, right? Yay, good job. If you were able to do the same, congratulations. There. So with this project, we will be able to control other components like robotics, like the maximum sensitivity of the robot and other things, volume, lights, okay, or the intensity of any other component we will be able to control. All right, so that's it. Okay, so you can review this video if you like, and I encourage you to do the same. You must work with your Arduino and make sure everything is perfect before you put the power on, so that we will not damage anything with our Arduino. Okay, with that being said, I hope you have done yours too. We'll go back to my slide and finish the topic. Just in case you have some questions or if you're facing some difficulties, yes, you can do that. You can look for the connection. You can look for the diagram. This is the diagram. Check the connection. Okay, check the value and make sure that you have the correct code. Okay, with that being said, see you on our next lesson.